In this video, we will be discussing areas of regular inscribed polygons. So we already covered in class what an apothem is and exactly how to find the central angles and how that's going to help benefit us when we're finding the total area. So first and foremost, the apothem looks like a height here. An apothem is going to be the distance from the center to the middle of a side of a regular polygon, and the radius is going to help us. So right there I just drew a right triangle. I went ahead and took the right triangle out here, and I even enlarged it. So all I have right here is my hypotenuse of a little right triangle that I drew using the apothem, which is 5 centimeters. So now I need to figure out some of these angles. So I'm going to go ahead and use my knowledge of a circle, and I'm going to break it up into some equal triangles here. Alright, okay, so if I actually break it all up into equal triangles, I know that it is a hexagon. So I want to take 360 degrees at the center and divide it by 6. Alright, so 6 angles here, divided by 6. So each one of those central angles is going to be 60 degrees. Alright, so this right here is 60 degrees. However, this angle is going to be exactly half that. So in each one of these right triangles, this is a 30-degree angle. Alright, which makes this a 60-degree angle down in the bottom left. Alright, so using these three pieces of information, I should be able to use sine, cosine, or tangent. So I need to write out SOHCAHTOA. So it's going to benefit me to find the apothem. Alright, so according to, let's just go ahead and use that 30-degree angle that we found. According to that 30-degree angle, my apothem is adjacent, and I'm given my hypotenuse, so I need to figure out which trig function has adjacent and hypotenuse, and that's going to be cosine. So I'm going to be using the cosine of 30 degrees equals adjacent over hypotenuse, so I'm just going to put A for adjacent, or A for apothem, it actually works out there, over 5. Alright, and so in order to solve for A, I multiply each side by 5, and I get 5 times the cosine of 30. Alright, so A approximately equals 4.33 centimeters, which makes sense. It should be smaller than our hypotenuse. Alright, so now I can use the area of a regular polygon in its formula equals 1/2 the apothem times the perimeter. So right now I do have the apothem, so that is a check. I've got 1/2 times approximately 4.33, and now I need to find the perimeter. So I'm going to go back up to my triangle here and see if I can go ahead and use my new knowledge. Alright, that this is 5 and this is 4.33. I also have 30 degrees in here and 60 degrees. I could use another one of my trig functions, or I can use the Pythagorean theorem to find my third side. So I'll just go ahead and use the Pythagorean theorem. Pretty good at that. So I'll make this b. So b squared plus 4.33 squared equals 5 squared. Now I do want to bring to your attention what I say in class. I've already rounded this value here, so my b might be slightly off because I'm using another rounded value. Alright, so I get b squared equals 25 minus 4.33 squared, and then I'm going to go ahead and take the square root of that, so b equals square root of 25 minus 4.33 squared, and that's going to approximately equal 2.50. Alright, so now I've got, sliding it all the way over to see my original figure here, if this little piece right here is about 2.5, that means this is 2.5, which means an entire side here is going to be 5 centimeters. Which also means, since it's a regular hexagon, I just take that 5 centimeters and I multiply it by 6 sides in order to get my perimeter. So I'm going to scroll all the way back here. Alright, P perimeter equals 5 times 6 sides, which equals 30 centimeters. Alright, so now I can substitute 30 in. Alright, and then I can go ahead and multiply. I know 1/2 of 30 right away, so I can do that times 15 and get my final answer. The area of this regular polygon is approximately 64.95 centimeters squared. Alright, this is a long, messy process. However, the biggest pointers that I can give you is to write out SOHCAHTOA and to figure out what information you're given. Are you given the hypotenuse? Are you given opposite or adjacent? You first have to pick an angle that you're talking about there and decide according to that angle which sides you have. And so then you can figure out more pieces of information from there. And you can also use the Pythagorean theorem to help you out as well. Please feel free to see me before or after school if you guys have questions, or send me an email. I'd be more than willing to help you guys out in finding the area of regular inscribed polygons.